Hello, GopherCon Europe, and welcome into the dependency jungle. My name is Dan Lorenc, and I'm going to be talking about supply chain security and Kubernetes. In this talk, I'm going to cover a couple different trip reports and case studies of some time I spent trying to improve the supply chain security of the Kubernetes dependency tree. I'll go over a couple examples in detail, and then also cover some lessons I learned along the way. So we're going to start out by focusing on CVEs. I ran a couple different open source scanners on the vendor tree of Kubernetes and tried to fix up some high security CVEs I found. I'm also going to talk about some proactive steps I took at the end to try to trim the dependency tree to make it so there are fewer things in there and it would be easier to fix CVEs in the future. Some of these are pretty fun and there's a little challenge at the end as well. During my time in the dependency jungle, I did spend a while in there. I aged quite a bit. You can see what I look like at the start of this and what I look like now. This trip really took some time off of me. Starting out though, fixing CVEs. CVEs are pretty scary, but not all of them are always going to affect you or your code. Just because the CV shows up in your dependencies doesn't mean it's necessarily a vulnerability in your application. Not every code path gets called. Not every CV is actually exercised by every single line of code in every library. So you do have to look at these in detail to figure out if you're affected by them in a lot of cases. Fortunately, having them show up in your scanner means it's harder to tell which ones actually affect you in the future. So trying to keep this number down is good, whether or not it actually affects your code. I started out here with a couple different examples from a scan I took back in, I think it was around December of 2020. So here's what that scan looked like. I think there are about 20 results total. I used Snyk for this scan. There are a bunch of other excellent open source scanners like Trivi and a bunch of other products as well. I think there are about 20 total. I focused in on these three, which had the highest severity. They kind of show up at the end in bright red if you do a Snyk test on the Kubernetes GitHub repo on your local machine. These showed up in December of 2020. So they might not be there today. Actually, one of them still is, unless it gets fixed in between the time I recorded this and the time this talk is shown. The one there at the bottom. You can go to the URL here to figure out more information about each of these to figure out if it actually affects you or not, and sometimes even some steps you can take to fix them. I started at the top here. I'll go through some of these a little bit quickly because they're not all terribly interesting, and a lot of it does get kind of boring and rote, which is probably why they're still here. This is one of the saddest cases, and it comes up quite often. When there is a dependency that's in use by a bunch of packages, you may not even use it directly. It might be something that's used by a dependency of your dependency of your dependency, pretty far down the tree. Go UUID is an example of one of those, where something gets widely used because it's one of the first libraries to do something, and it gets deprecated or it gets unmaintained over time. Open source code is just that. It's code that gets published on the internet where anyone can read or use it. The author is under no obligation to keep maintaining this code for you. And in a lot of cases, that happens. Somebody stops, walks away from a project, and it keeps getting used. That's what happened here. If you go to this repository, you'll see stuff like this immediately jump out to you. These are signs of a zombie dependency, I call them. A bunch of PRs trying to add deprecation notices, trying to mark the repo as archived, and no maintainer around to actually merge any of these. This is generally harmless, although you don't really want too many of them because they can build up. The problem comes when a CVE is found in one of these or a security vulnerability. There's nobody around to merge the fix, then it sits there. Projects have to make the tough choice between forking it, switching to a different version, renaming it, deleting the dependency completely. It gets tricky, especially when we're in an interconnected web of dependencies. Everybody has to do this in coordination to get it done quickly. This bug was an insecure randomness issue, so it might not have affected you depending on how you're using these UIDs and what random number generator you're using, but it's still bad to have a high severity vulnerability show up. So I tried to delete it. A lot of these you can fix just by updating your way out of it. Go mod Y is an excellent tool to analyze your dependency graph if you're using Go modules. It shows you the actual import list. So from your application down the shortest path to the dependency. This one here, you could see the actual Kubernetes code. The first line, the CMD Cloud Controller Manager line, that's the code that kind of causes this to all get pulled into the Kubernetes tree. This uses some cloud provider stuff, which uses the Azure client libraries for storage. which imports some UUID, this UUID library. This took a little while to get fixed. It was finally merged April 23rd, 2 weeks before I recorded this talk, into the Azure Go SDK. I tried to send the PR much earlier than this, but it got tied into a bunch of other changes that were being made in the Azure Go library, so it took quite a while to get merged and get released. From the time Azure actually did this release and picked up the update by switching to a different UUID provider, Kubernetes then had to take this and apply this update. This is pretty simple because there was nothing else in the way. You can imagine it being even worse if there were some other libraries in between the Kubernetes legacy cloud provider and then Azure SDK for Go showing up here in the graph. We'd have to wait even longer. Second one. So the first one has been fixed in Kubernetes now. The second one was in a DNS library. This one was even simpler. I was actually able to send a pull request to fix this back in December. Because this one was simpler, it's a direct import of Kubernetes. So we see here Kubernetes PKG proxy Windows user space directly imports the DNS library at the version that was vulnerable. This library is still maintained, so we don't have to switch off of it or anything like we did in the previous example. Instead, we just have to update. This was done backwards compatibly. There were no issues or anything. I sent the PR. It still took about 3 weeks to get merged. It was right around the holidays. Nobody was going to do a release anyway around then. And actually, some of the delay was because the Kubernetes maintainers saw that this library was only used in a couple places, and it might be easier to actually just rip it out completely. So they spent a couple days trying to rip it out completely, realized it was a little bit thornier than they thought, open an issue to do that later, and then merged my PR to fix this. So this CV 2019 19794 no longer shows up in the Kubernetes tree if you run a sneak scan. So these are the easiest ones. They still have to happen though. I don't know how long this showed up in the Kubernetes tree. The CV was reported back in 2019, so it could have been a whole year before it was fixed. And it took me almost a month to fix it just when I was trying. If I hadn't done that, it might still be showing up in there today. Even things that are pretty simple and take about 15 minutes to write the PR for. Now on to the final one. This is one that is still present if you scan Kubernetes. It's an issue with the JWT Go library. It does still show up if you look in the Kubernetes tree, but I've looked at the code. I'm not a JWT expert. I don't think this actually affects Kubernetes in the way that they use JWTs today. But who knows? If a new usage of JWTs pops up, it could start using these vulnerable code paths. So it's important to get rid of these early. This one is just like Go UUID, unfortunately, where the repo is no longer maintained. And this has been in an abandoned state for a little bit longer. If you go to this repository, you'll see a ton of issues like this. People discussing forking, people discussing renaming. It's open source, and there are no norms published around this. We don't really have standards or policies. There's always general hesitancy to fork code in open source. Forking is always considered bad, so people don't like to do it. If too many people try to fork it at the same time too in order to apply a fix, that can make it even worse if people apply different fixes and now we have 10 different slightly incompatible versions of the JWT Go library flying around. That's going to complicate meta trees even more and make maintenance even harder. This is a pretty sad case of all of that, still affecting much of the Go module ecosystem. Again, like I said, this is still present in Kubernetes, but I have looked. I don't think we're disclosing any vulnerabilities here today. But if it is in Kubernetes and you're using Kubernetes, it might be in your tree. So I would urge you to go look if this is affecting your code. I tried to remove it unsuccessfully. I did move things forward a little bit, and I got a bunch of PRs merged that I think will make it easier to remove this eventually, but I haven't gotten all the way yet. I'll explain what I did, and maybe somebody watching this talk can help finish it and get this out of the tree forever. Starting again with Go mod Y, we can see the import path and how it gets into Kubernetes. There is one package in between Kubernetes and JWT Go, so we can't directly fix it or directly replace it in Kubernetes. So I started here. It is the Haketi project. Jumped over to that GitHub repository and got my first warning sign. We're trying to remove a deprecated library, but it's actually depended on by another deprecated library. Haketi, this PR was merged right around the same time, or I think it was open when I went to send my first PR and noticed the maintainers of Haketi were announcing that the project is in hard maintenance status. Having the maintainers merge this is 100 times better than having a whole backlog of PRs trying to announce this from other people that are not maintainers, though, because it means there's still enough people around to merge a PR declaring that they won't be doing much maintenance going forward. So some bad, some good. Because the maintainers were around and opened this, I decided to give it a try and send a patch to switch off of JWT Go. I sent this. There were a bunch of CI issues. Again, this isn't under active maintenance. The maintainers were a great help. I think I even still had to install Glide and get some containers with like a very old version of Go running in order to test everything, get tests passing, show that the CI flakes weren't my fault, have the maintainers keep rerunning CI for me, that kind of thing. So it took about 2 months to get this swap in, and this is from the deprecated JWT Go to a fork that's completely backwards compatible, requiring the minimum number of code changes. Really just had that one fix applied. So this took a long time. At the same time, though, I decided to keep looking. Go mod graph shows you the shortest path from your code to a dependency, I mentioned before. If you remove that one, there might still be more paths, right? It kind of stops the first occurrence it finds as it searches the tree or the graph. There can be other ones, and you can find those other ones with go mod graph, like I show here on the right-hand side. This will actually show you all of the nodes in your tree, and you can filter that with grep or other tooling to visualize and see all the different ways something might be coming in at all the different versions. I found a few more and decided to send some more PRs to try to boost this. Another one here where I started to get stuck and realized something pretty interesting that I didn't know originally is that you can get import cycles in Go with modules. They're not the import cycles that you might be familiar with battling when one of your packages imports another one of your packages, which imports the original one. These are a little bit different. They're not harmful really, except for when you're trying to break out of a deprecated dependency like this. And I'll show why that got complicated. But let's start at the beginning. So if you're looking in Go mod graph and that output and Go mod Y, you can see that etc, the database that's used by Kubernetes to store all objects, uses JWT Go. etc supports a bunch of different authentication mechanisms. JOTs or JWTs are one of them. So it uses this JOT library. I looked in the etc code again. I don't think it's vulnerable to the CVE that was found here, but I am not an expert in JOTs. So etc uses JOTs, and then Viper, which is a command line tool, actually uses etc. Viper is a very popular configuration package for Go. It allows you to have configuration for your application that lives in file, on disk, in environment variables, and command line flags, and cascade them all in an orderly manner so you can override settings in a predictable way. It also supports storing configuration or pulling configuration from etc because etc does expose a configuration interface. So etc uses JWT Go, and Viper uses etc. So that's how JWT Go shows up in the Viper dependency tree. Here's where the cycle comes in, though. etc uses Viper. Viper uses etc. etc uses Viper. How is this possible without creating an import cycle? So I did send some PRs to etc and Viper. So here's what it looks like. Here's how you can have circular imports without cycles. Your app imports etc at one version. That version of etc imports Viper at an older version. Viper imports the newer version of Viper that your app imports directly, imports etc at an older version. The Go mod tooling will resolve this and pick the right versions of everything for you, but it means that you have a little bit of a cycle here. JWT Go is used by both of these. So in order to update both of the libraries to get rid of JWT Go, you need to first update it in both etc and Viper, and then update the versions of etc and Viper that are used by your application. I was able to send a PR to etc to get that updated, and now the new version of etc doesn't use JWT Go anymore. The maintainers helped me get that merged. There were some issues getting it updated in Viper, but that maintainer very recently, I think in the last couple of weeks, was able to remove JWT Go from Viper, but it is still showing up in the Kubernetes dependency tree. etc is used widely throughout the whole code base, so updating to a new major version of etc inside of Kubernetes is going to be a lot harder than just doing a quick Go module update. So that's why it is still present there. All right, CVE is where I spent most of the time. I did try to do some kind of proactive work and trimming the dependency tree. When I was looking in the Go mod files, I saw a couple strange packages that I wasn't quite sure why they were present in the tree. So I took a look and played around to learn about how hard it is to actually remove things like this. This is what I saw. I was looking around trying to read the way the file was structured, and I noticed a couple packages here. I don't really know why these stood out to me. The rsc.io quote and rsc.io sampler packages. It's written by Russ Cox. He is one of the core maintainers and leads of the Go programming language, and he's written a ton of Go code published under rsc.io that is used by a lot of packages and is well maintained and belongs in dependency trees. But for some reason, these ones looked weird. I wasn't quite sure what the quote library or the sampler one were doing. So I decided to hop over to that GitHub repo and take a look. And that's when the first kind of WAT moment hit me. This is a very small package. It only has a license file, a test, and basic Go mod. I don't know why we would have a hello.go imported into the Kubernetes tree. So I took a look, and the confusion did not cease. This is what the sampler.go file looks like. It's kind of nonsensical code. There's a single variable, 99 bottles of beer on the wall. It looks like it has something to do with translation, but there's no actual translation code here in the repository. I was confused. What is this nonsensical code doing on GitHub? Is it some kind of sample? If so, how did it make its way into one of the most widely used Go projects in the world, Kubernetes? So back to Kubernetes, and I reran my trusty go mod y command from earlier. And this is the first time I saw this output. The main module does not need this package. And that was confirmed. I searched the Kubernetes tree, and nothing was importing this directly in the code. It was not actually showing up in the vendor directory. So why is it in the go.mod file? Thought maybe it was some kind of mistake. Maybe they weren't doing go mod tidy. So I tried to delete it. Rerunning all the tools and vendoring tools made it pop back up. So it belongs here. We still don't know why. I kept thinking, I remember there's this notion of test dependencies. So if a dependency of one of your dependencies is only present for tests, or it's hidden behind different build flags that you don't use, or Go tags, it won't make it into your application, which is great. We kind of do some pruning of the tree proactively. But it is clear that this version is still necessary for the constraint solving that Go.mod does as it tries to figure out the correct versions. But I was still curious, so even though it wasn't in the vendor tree, what was pulling it into the constraint calculation and why? Go mod graphed to the rescue again. If it's not showing up in Go mod Y, it will show up here because this catalogs every single node in the graph if you want to visualize it. I could see that the quote slash v3 library was pulling in sampler, and quote slash v3 itself was pulled in by golang slash mock. Mock is a popular test library, so again, it confirmed my suspicion that this had something to do with the test dependency of a test dependency. Still, I wanted to see if I could remove it. So I hopped over to golang slash mock and saw that one of the most recent fixes actually was to remove this as a dependency. It was commented out here. I was still trying to figure out why it was brought in the first place. So I kept clicking around and did a bit more digging. And saw that it was put in mistakenly. So I was able to get it removed just by bumping golang slash mock in Kubernetes. Still curious though, I kept looking to figure out why it was in Golang mock in the first place. And the reason there was that the sample code that Russ published was actually just to show how major version transitions between Golang modules worked as part of the Go modules rollout. Golang mock had a bug where it wasn't parsing import paths correctly for things using major versions and modules, so they added that as a test case. It was removed because it was showing up in a bunch of places like this that it shouldn't have been, so it was taken out of the test. Bumping this was enough to clean up and remove a few things from the Kubernetes go.mod file, so this PR got merged pretty quickly. There is still one challenge though. If you were looking closely at the Go mod file, there were 3 rsc.io packages in there. I only removed the bottom 2. The first one kind of confused me as well. This is rsc/pdf. This is an actual PDF parser that Russ wrote a long time ago in Go, but it's no longer maintained. He's archived it. Why would a PDF parser be present in the Kubernetes code base in the first place? We don't support kube control apply with a PDF file. We have YAML and JSON, and those are challenging enough to work with. So I did some digging to figure out where it was coming from, and I actually spent a bunch of time trying to remove it myself. It turns out this isn't the only PDF parser in the Kubernetes code base, and it's not even the only archived one in the Kubernetes Go mod file. A lot of these are similar where they're not actually showing up in the real vendor directory if you build it, but they are test dependencies, and it does kind of vary. I wasn't able to remove this because of a bunch of challenges, like circular dependencies and needing to bump a whole bunch of things at the same time. So I've left this one here as a challenge. If anybody's able to get this removed from the Kubernetes vendor tree, reach out to me on Twitter or email, and I'll send you some kind of prize as a reward. Here it is if you're interested in the exact line. At the time I took this, it was right around line 532. I'm sure it's changed since then, though. But if you open up that Go mod file today, you'll see it in there somehow. Don't want to give away too many hints of the stuff I tried, just to kind of keep the surprise and challenge going. All right, so to summarize and wrap up my talk, updating CVEs, even when there's a fix already available and it's backwards compatible, and all you have to do to update it is to update your dependency is slow. It takes on the order of weeks, and nobody's actually actively doing this. I happened to have some time off in December, so I tried to play around with this and do it myself. If I hadn't done it then, who knows how much longer it would have taken to get started. A lot of these had been sitting around for close to a year before I came along and started trying to fix them. I think we really need to make this easier to do. We need to make it easier to get these changes merged, and we need to prioritize it. If projects start getting their count down on these scanners closer to zero, it'll be easier to stay there closer to zero, which will make it easier to notice when real ones do crop up. I think we also need a way to deal with widely used abandoned dependencies across the ecosystem, like the Go UUID and JWT Go libraries. Open source culture in general really frowns upon forking without the intent to contribute things back. It's seen as a large kind of move you don't do without thinking carefully. Unfortunately, when something like this is abandoned, we need to fix vulnerabilities every day, every week counts. We need some kind of playbook to do this in a central way too, to avoid the fragmentation issue I discussed before. If everybody just goes and hits fork at the same time and writes their own fix, that's almost just as bad as nobody being willing to hit fork. So we need some kind of middle ground. Supply chain security is important. It affects everyone because these dependency graphs get so complicated. So we need to make all of this easier in order to improve all of our own security. Well, thank you. That's all I have for today. You can reach out to me with any questions, or if you manage to get that PDF library removed, my contact information here.